How does psychrometrics work for HVAC system design? Imagine trying to keep a building comfortable no matter what the weather throws at you. That's where understanding how moist air behaves becomes a game changer. Psychrometrics is the science behind that understanding. It studies the properties of moist air and how they change during heating, cooling, humidifying, or dehumidifying. In designing heating, ventilation, and air conditioning systems, it helps engineers predict how air will respond to different treatments. At the heart of psychrometrics are key measurements. Dry bulb temperature is the actual air temperature you feel. Wet bulb temperature reflects moisture content, measured by a thermometer with a wet wick. Relative humidity shows how much moisture air holds compared to maximum capacity at that temperature. The humidity ratio tells us how much water vapor is in the air compared to dry air. Enthalpy measures the total heat content, combining sensible heat and latent heat. These values are plotted on a psychrometric chart, which looks like a colorful map for air conditions. Using this chart, engineers can visualize how air moves through different processes. For example, when cooling air in summer, the system removes sensible heat to lower the temperature and latent heat to reduce moisture. The chart helps determine the exact temperature and humidity of the supply air needed to keep indoor conditions comfortable. It's like a blueprint for how to adjust air properties effectively. Psychrometrics influences many parts of HVAC design. It helps calculate heating and cooling loads by showing how much heat needs to be added or removed. It guides ventilation planning to ensure fresh air is supplied without overloading the system. It also aids in designing humidification or dehumidification processes to keep indoor air quality high. When selecting equipment, the calculations tell us what size fans, coils, and ducts are needed. This ensures the system runs efficiently and uses energy wisely. In practical terms, psychrometrics allows engineers to convert thermal loads into airflow rates. If a space needs a certain amount of cooling, they can figure out how much air must flow through the system. This helps in choosing the right air handling units, fans, and duct sizes. It also ensures the mechanical room has enough space for all the equipment. When designing HVAC systems, engineers combine these psychrometric processes to create complete cycles. For winter heating, they adjust supply air temperature and humidity to offset heat loss and maintain comfort. The psychrometric chart helps find the perfect balance between sensible and latent heat. This way, the system can deliver the right conditions efficiently. Overall, psychrometrics is a vital tool for mechanical engineers. It provides a clear, scientific way to analyze air properties and design systems that keep indoor environments comfortable, healthy, and energy efficient. By understanding these principles, engineers can build HVAC systems that perform reliably and meet the needs of any building.